Welcome to AB Academy. Gas chromatography or GC. Definition, components, working. Firstly, let us see definition of gas chromatography. Gas chromatography is an analytical chemistry technique used for separating and analyzing compounds that can be vaporized without decomposition. The gas chromatography is a chromatography technique used for the separation of volatile compounds. Volatile compounds are the compounds that gets easily vaporized at room temperature. We'll see the different components of gas chromatography. The column used in a gas chromatography is very long and arranged in a coil. The column used in gas chromatography are of two types, packed column and capillary column. Packed column. Packed column can be made up of glass or stainless steel. The length of this column can vary from 1 to 5 meters and has an internal diameter of 2 to 4 millimeter. The capillary column. The capillary column is made up of fused quartz. These columns are very long and have length from 5 to 100 meters and have an internal diameter of 0.1 to 1 millimeter. The column is placed in the chamber so that a uniform temperature can be maintained. The next component is stationary phase. The stationary phase is packed in the inner wall of the column. The stationary phase is made up of silicon grease or wax, which can withstand a high temperature. The mobile phase. The mobile phase is usually an inert gas like helium or unreactive gas such as nitrogen. The mobile phase gas is kept in a cylinder which is connected with the column via molecular sieve. The molecular sieve separates unwanted hydrocarbons, oxygen, and water vapor that may interfere with the test sample during analysis. At the end of the column, there is a detector which detects the sample. Let's see the working of gas chromatography. The sample which is to be separated is mixed with appropriate volatile solvent such as acetone, heptane, or methanol. Just before the column, there is a septum that allows the injection of the sample. The temperature of the injection region is kept 20 to 50 degrees Celsius high as compared to the column. This allows rapid volatilization of the sample. Once the sample is volatilized, it passes down the column where the separation occurs. During analysis, the temperature of the column is kept between 150 to 300 degrees Celsius. Separation occurs based on the interaction of molecules between the mobile phase and the stationary phase. The less volatile molecules interact more with the stationary phase and move slowly, while the more volatile molecules interact more with the mobile phase and move fast down the column. Once the separation is completed, the detection is done with a detector attached at the end of the column. One of the most common detector used with gas chromatography is flame ionization detector or FID. The flame ionization detector has three inlets, one for the carrier gas which comes from the column and the other two for hydrogen and oxygen. The igniter ignites hydrogen and oxygen to produce a flame. When the sample molecules reaches the flame, they get ionized and electrons are released. Across the flame, there are two electrodes, each with a positive and a negative charge. The electrodes detect electrons generated by the ionization of the sample. Electrons are detected in the form of current which is amplified and detected by the computer. When the sample is detected, the computer gives a peak with respect to the retention time of the sample. The area under the peak gives information about the concentration of the sample. If the concentration is less, the area under the peak will be less, and if the concentration is more, the area under the peak will be more. Thanks for watching. Please like, share, comment and subscribe my channel.